Hi everyone. So we're going to continue here with our discussion on the history of the nuclear model of the atom. Remember in the previous video we talked about how the electron was discovered by J.J. Thomson and the experiment with the cathode ray tube. In this video we're going to spend some time talking about how we discovered the charge and mass of the electron, and this was an experiment that's performed by Robert Millikan. So here's a brief summary of what Thomson did and what we talked about in the previous video. But basically at the end of his experiment he discovered that the cathode ray is composed of negatively charged particles, which was later called electrons. Now, one thing that I want to describe a little bit is that Thomson was able to determine something called the charge to mass ratio of the electron to be a certain value, which is given here. And this should be actually negative number here. But the value is negative 1.76 times 10 to the 11th coulombs per kilogram. So let me just mention what this charge to mass ratio is. So you remember that in the cathode ray tube experiment, what he was able to do was he was able to influence the direction of the cathode ray, in other words, bend the cathode ray by applying an appropriate magnetic or electric field outside. And so the degree of bending, he concluded, because these are composed of particles, he concluded the degree of bending will depend on how heavy the particle is, which is the mass of the particle. And then, because the particles are negatively charged and they interact with these positive and negative electric field, then the degree of bending will also depend on the charge of the particle. So in other words, both mass and charge will influence the degree of bending of the particle, of the electron. Unfortunately, with the type of instrument that he was able to use at the time, he wasn't able to determine what is the exact mass and charge of the electron itself. But what he was able to do was he was able to use experiment to determine the mass, the charge to mass ratio. So in other words, the actual, the charge divided by the mass was what he was able to determine, and that's what this number represents, negative 1.76 times 10 to the 11 coulombs per kilogram. Coulomb is a unit for charge. Now if you look at this number, you notice that it's a pretty big number, right? 10 to the 11 is a big number. So that implies something about the electron. The electron must be a particle that has a relatively small mass, right? Because this is a charge to mass ratio, the mass is at the bottom, the denominator. The mass must be a really small mass, yet the charge is, with respect to the mass, is a fairly large charge. Okay, so the question then from here on is, what exactly is the charge and what exactly is the mass of an electron? Because if we really want to know how the electron works, we need to know those two properties individually. We can't just use the charge to mass ratio, because that doesn't provide us with exactly what is the charge and what is the mass of the electron. So now we're going to move on to Millikan's experiment, which is often called the oil drop experiment. And this was the experiment that ends up showing us, allowing us to calculate what is the mass of the electron, because he was able to use this experiment to determine the charge of an electron. So let me describe the setup of the experiment really quickly. The way Millikan did this was the following. So he started with a setup that looks like this. So there's a chamber here. Inside the chamber there's two electric plates. One is positively charged, the other one is negatively charged. And he has basically kind of a power source of some sort that allows him to control the voltage that's exerted by this charge plates. Okay, so he can he can basically control how much voltage difference there will be in between these two charge plates. So what he did was he had a canister here, or a can containing oil, and then the oil is being sprayed, and when it comes out of this spray it becomes these small drops of oil. So this is very similar to if you're using something like a WD-40 or something, when you're spraying it, or when you're spraying anything, you have a can and then you spray out, the substance comes out as drops. So the drops, as you'll see in this animation, the drops, once it's sprayed out from the can, would just drop down to the bottom because of gravity. Okay, so all droplets have a certain mass, and they're just going to fall down to the bottom because of gravity. And in the first part of the experiment, what he did was he just wanted to know what is the mass of these oil droplets. So he used kind of classical physics calculation using Newton's equation to determine what is the mass of each of these oil droplets. Okay, and then the next part of the experiment is the following. So you see that oil droplets just falling down to the bottom because of their masses, right? So at this point, the only force acting, so if you think about the force acting on these oil droplets, is just gravitational force. So the only thing that's happening to these oil droplets is being, going down to the bottom because of attraction to the center of the Earth. Okay, now once he did that first experiment to figure out the mass of the oil droplets, the second part of the experiment was then he had an X-ray source, which is then shine onto the this part of the chamber, and this part of the chamber contains air. So when X-rays shine on the air around the oil droplet, what happens is then the electrons on air would be ionized. In other words, I should say the air would be ionized, and what that means is the electron is kicked out from air, and because the electron can't just float around, it jumps onto the oil droplet that's falling down. Okay, so let me just show you in terms of animation what happens there. So he's shining this X-ray, and you can see it through the microscope here. It's gonna what's happening to the oil droplet. So when the you can see here that it's marked as negative. The reason is because the the electrons from air around this, which has been ionized by the X-ray, then jumps onto the oil droplet, and there's variable number of electrons that are going to be on this oil droplet. So you might have 10 electrons here, you might have 20, you might have 100. So different numbers of electrons are on each oil droplet. Okay. Now, what's interesting, of course, now is that you notice what happens here. He starts to turn on this voltage, which, remember, controls the strength of these electric field that's exerted by these two plates right here, these positive and negative plates right here. And you notice what happens as he does this to the oil droplet. So watch what happens there. Okay, so you notice what's interesting is that first off the oil droplets slow down, and then at some point the oil droplets start to move up, right? And so what's happening there? Well, remember what he did here was he turned on that electric field. So this plate here is negatively charged, this plate is positively charged. So because these oil droplets are negatively charged because they have electrons on them, they're going to be repelled by the negative plate and attracted by the positive plate. So at some point they start to move up, and they're only going to, but remember, they have to fight gravity, right? So gravity is pulling them down, but this electric force is pushing them up. So there's a point, if you control this voltage appropriately, there's a point when what? When the droplet is exactly suspended right in the middle, because that's when the gravitational force, which is pulling this thing down, and the electric force, which is pushing it up, is exactly balanced with each other. And that's actually an important condition. When you have that condition, you can then determine how much charge is on each of these droplet, or in the droplet that's suspended. Okay, let me show you how this happens. So the first thing to realize is, what is the force due to gravity? Well, it's just given by this equation, m times g. In this particular class, because we're talking about chemistry, you don't really need to know this at this point. This is a physics equation. I'm not expecting you to be able to make any calculation with it, but you do need to know that the gravitational force in this case is given by m times g. M stands for the mass of the oil droplet. G is just the acceleration due to gravity, which on Earth has a constant value. Okay, now remember that when the oil droplet, he turns on that electric field, you have this other force that counteracts the gravity force, which is the electric force, and the electric force is given by this equation, Q times E, where Q is the charge of the oil droplet and E is the size of the electric field that's given by those two plates right there. Okay, remember that when the oil droplet is exactly suspended in the middle, the two forces are equal to each other. So Q times E is equal to m times g. Now remember, what he wants to determine here is the value of Q, which is the charge on the droplet. So if he knows all these three, which he does, he knows this because that's a constant. He knows the mass of the oil droplet. He could measure that. He knows the E because E is what he controls using that box earlier that I was showing you. He controls it using this. So as a result, he knows all these three components. So he can use that to calculate Q. And Q, of course, is the charge of all the electrons on the oil droplet. Now, when he did this for a bunch of different oil droplets, he found that the Q that he got from making all those calculations is always a multiple of this number right here, which is 1.6 times 10 to the minus 19 coulomb. Okay, so in other words, he might get something that's 10 times this number, something that's 20 times this number, or something that 100 times this number. So what that tells him at that point is that this value must be equal to the charge of one single electron, because we can have, remember, a lot, different number of electrons on the oil droplet. We can have 10, we can have 20, we can have 100. But if all those numbers are always a multiple of this number, this must be the charge of just one electron, because everything else is 10 times one electron, 20 times one electron, and so on. Okay, now once he was able to determine that this is the charge of one single electron, he then can go back to the charge to mass ratio that Thomson figured out from his cathode ray experiment. This is the charge to mass ratio, and then this is the charge value. And using dimensional analysis, you should be able to figure out the mass of an electron. Okay. In fact, I'm going to leave that as your homework. Okay. So figure out the mass of a single electron using the charge to mass ratio and then the charge that Millikan figured out. All right.